Okay, so this is still section 2.1. I was wanting to finish this up in this this video here. Let's consider the set of all x such that x is an odd integer between -8 and 7. Use set notation and the listing method to describe this set. Okay, so I'm using the listing method, which means that I would just list the numbers that I am talking about here. All right, so an odd integer between -8 and 7. Okay, so -8 is not odd, so it go -7, -5, -3, -1, 1, 3, 5, and now do I want 7? No, because I want all the odd integers between -8 and 7, so that does not include -8 or 7. Problem 12, consider the set which is the set of all x such that x is a negative multiple of 6. Okay, use set notation and the listing method to describe the set. Okay, so a negative multiple of 6 means I got 6 times -1, that's -6. 6 times -2, that's -12. 6 times -3, that's -18. 6 times -4, that's -24. And I would just list all those. Of course, this set would be infinite. Okay, since the ... would mean that the list never ends there. Consider the set, which is the set of all x such that x is a positive integer power of 4. Use set notation and the listing method to describe this set. Okay, a positive integer power of 4. So that means I got like 4 to the first would be 4. 4 squared, that's 16. 4 cubed, 4 times 4 times 4, that'd be 64. 4 to the fourth power, 4 times 4 times 4 times 4 times 4 gives me 256. And then 4 to the fifth power would be 1024, and 4 to the sixth power, okay, etc. Problem 14, consider the set, which is the set containing 35, 40, 45, 50, etc., all up to 95. Use set builder notation with x as the variable to describe this set. Okay, so I'm using set builder notation, which means that I have the set of all x, and then such that, and then I got to explain what's happening to x here. So x, here's one answer that I've got. X is a multiple of 5. Okay, so between 30 and 100. Now, if you're between 30 and 100, that does not mean that you include 30 or 100. Okay, and there's several answers that I could give here. I could say the set of all x such that x is a multiple of 5 between 33 and 97. Okay, well, 33 or 97 are not multiples of 5, so that disregards the endpoints altogether, and I would still get the same answer. Okay. Problem 15 says consider the set Alaska, California, Hawaii, Oregon, Washington. Use set notation and the word description to describe the set. Okay, so one answer that you could give is the set containing all U.S. states that touch the Pacific Ocean. Okay, that would be these 5 states that are listed there. They all touch the Pacific Ocean, and so that would be one answer that you could give there. Okay. Definition: a set is finite if it has a cardinal number that is a whole number. A set is infinite if it is not finite. Okay, so a cardinal number that is a whole number. Okay, well, let's look at some examples. So problem 16, identify each set as infinite or finite or infinite. Okay, so part A, we got the set containing 3, 6, 9, etc. Well, the etc., or the ... would mean that this list continues and it never ends. So because it never ends, I can't identify a cardinal number to this set. Okay, that's to be an infinite set. Part B, the set of all x such that x is a natural number less than 50. Okay, so a natural number, remember that's a number that is 1, 2, 3, 4, 5, okay, or more. Now I'm less than 50, right? So there'd be the cardinality would be 49. If you're less than 50, you're not including 50. Okay, and so that'd be a finite set if you're starting at 1. Part C, the set of all x such that x is a rational number between 0 and 1. Okay, that would be infinite. So rational number, now I've got a start point and end point, but the question is, okay, how many fractions are there between 0 and 1? Okay, well, there's infinitely many of them. Okay, and one way that you can see this is just to begin listing, which would be impossible, but if you were to begin listing, saying at 1/2, 1/4, 1/8, 1/16, 1/32, okay, the denominator would be just a power of 2. Okay, the ... there would indicate that that trend would continue to infinity, and that wouldn't even give you all of the fractions, okay, because you'd be missing things like 5/8 or 3/4 or, you know, etc. So this is only the ones that include a 1 in the denominator, or in the numerator, okay? The symbol that you see here is used to show that an object belongs to a set. For example, if A is the set of all cities in Illinois, then we can write Peoria is contained in A and read this as Peoria is an element of A. Likewise, we could also write that Chicago is contained in A. When an object is not a member of the set, we would use the symbol that's got like a slash through it. Since New York City is not in Illinois, we can write New York City is not an element of A. And read this as New York City is not an element of A. Okay? So some examples here. Problem 17, you want to fill in each blank with either the symbol that means contained in or not contained in to make each statement true. Okay, so part A, 5 is contained in the set containing 2, 5, and 8. Yeah, that's true. So 5 is one element that I can see plainly there. Okay. Part B, 3 is not contained in the set containing 2, 5, and 8. Okay, so 3 doesn't belong in that set. So I'd make sure to have a slash to that sign. Part C, 27 is not in the set containing 1, 5, 9, 13, 17. Okay, it looks like I'm going in an increment of 4, so 17, 21, 25, 29. Okay, so 27 would not belong in that set there. Okay. Part D, 0 is not contained in the empty set. There's nothing in the empty set. Okay, so to say that 0 would belong there, no, that's not true. Okay, nothing is in the empty set. Part E, map is not contained in the set containing M, A, and P. Yeah, so of course the thing to see here is that the commas matter. Okay, so I've got a set with 3 elements in it. Here's one element, not in this set. Okay, so you know, I'd make sure to have a slash through the symbol there. Part F, capital A is not contained in the set containing little a, little b, and little c. Yeah, that's true. So little a is in there, capital A is not in there. Okay, so here's an important problem that you know it is really about the difference between capital letters and small letters. You know, you got a set containing all small letters, so you should be using small letters. Okay, a little a would belong in that set. A big A does not belong in that set. Okay. Part G, the set containing 5 is not contained in the set containing 2, 5, and 8. Well, 5 is in that set, right? We said that earlier in part A. The set containing 5, well, that'd be different. Okay, so 1 is an element. The other is a set. Okay, now to make this true, part H, the set containing 5 is contained in the set containing 2, the set containing 5, and 8. Okay, that is true since I can see that element is a member of that set. Okay, so the set brackets absolutely are important for what we're doing. Part I, pi is not contained in the set of all x such that x is a rational number. No, so a rational number is just fancy words for a fraction, right? So pi is not a fraction, is the way that we translate that. Part J, Barack Obama is contained in the set containing all U.S. presidents. Yeah, that's true. Okay. Page 54, here's the homework that I'd like you to look at for section 2.1, and starting right below that, that's where section 2.2 will begin.